about this. It says, so first of all, it says, when does this reach its maximum height? The first thing to notice, you look at it and say, what am I looking at? Well, doesn't that mean we're looking at a parabola? Okay, the next thing to look at, do we see a negative? In front, where A is. Our A value is negative, so doesn't that make it a frowny face? So we have a quadratic that looks something like this. Now, keep in mind, if I was to draw a straight line like this, aren't these the x-intercepts? Yeah? Isn't that when we solve the quadratic? And then there's a lot of things that we know. We also know this. What is this called? An axis of symmetry and also a vertex. Very good. So it says, when does this reach its maximum height? If you solve it, won't you be finding this value and this value? That's not really going to help us a whole lot, is it? Okay? Wouldn't this be helping us a lot? Okay? Does everybody see that our vertex would be helping us? Isn't that the maximum height? So then we say, okay, we know that to find the vertex, you do x is equal to the opposite of b over 2 times a. That formula you've got to have down. So the opposite of b would be negative 40, right? Over 2 times a, which is negative 16. 1.25. So we get 1.25. So now think about it. That's x, right? So from here to here is 1.25. Now read the question. When does it reach its maximum height? Not where, but when. Isn't this time? The bottom. Guys, this is time, right? So isn't that after 1.25 seconds? Doesn't it reach its maximum height? So you'd say 1.25. That's when it reaches its maximum height. Now if I change the problem and said, where does it reach its maximum height, or how high is the maximum height, then we would find our y value by plugging in that 1.25 back into our function for t, right, everybody? Does that make sense, though? When it says, when does it reach its maximum height, it reaches it at 1.25 seconds. Is everybody comfortable with that problem? So if I put it on there tomorrow, you'll get it right. Okay, sweet. You will see problems like that on the end of the level, which really, that wasn't that hard, right? But you did have to know exactly what you're doing. How many got it right? Couple?
I did.
Okay.
I plugged it in there.
Okay, so just a couple little mistakes that we'll be careful of next time. Is everybody good with this problem? Okay, let's go on to today's lesson. So 7-4 was yesterday. We learned piecewise function. So I just want to remind you, we're going to be building on that today. Piecewise functions just means you have one function that contains pieces of other functions, of multiple functions. So this is just an example looking at it. This is a piecewise function. So we have this one function f of x, and it contains these two pieces. So we have a line and a quadratic. So we have the line 3x minus 2. We have the line 3x minus 2. We would plot it in. But we only keep that for x values greater than or equal to 1, right? So once again, the arrow's pointing this way. So that means we're keeping this side of the restriction zone, which is the red line at 1. So everybody see my red line at 1? My restriction zone. So we're keeping that side of the line. We kept that and we erased the bottom half, right, everybody? Then we also have our quadratic, x squared plus 3. So we plotted our parabola. Oh, sorry. It should have been negative x squared. So we plotted negative x squared plus 3. So we have this upside down parabola. And we only keep that for x values less than 1. So we have our restriction zone at 1. We only keep the parabola for x values less than 1, so that's why we kept the below part and we erased the above part. Is everybody comfortable with that? Okay, I am going to do one example real quick, so today it will seem easier for you. I promise it will. So we have this piecewise function. So we have this piece. Let's graph it first. So we have negative 2x plus 2. You have to be experts at graphing lines. You should be by now. You learned it in like middle school and then did it again in secondary 1. So we go y-intercept of 2, right? Now we have a slope of negative 2. Just a reminder, isn't that the same thing as negative 2 over 1? Yeah? So that's rise over run. So you go down 2 to the right 1. We always go to the right when plotting slopes, the beginning of your slope. So you go down 1, 2 over 1. I'm continuing that. Down 2 over 1. So then we go up 2 over 1, up 1, 2 over 1, up 1, 2 over 1. A way to check your line is to look at it and say, does it make sense? So let's look at it. Isn't this if you were to step on this, wouldn't you slide downwards? So make sure that makes sense. It's a negative slope. So you would slide down a slice. So we probably graphed this correctly. Now we're going to put in our restriction zone. I'm going to do it in red. Our domain restriction's at negative 2. That does not affect our graphs yet. So we're going to go ahead and put in our restriction zone at -2. So I go to -2, I put in my line. So we keep that function. So we keep that line for x values less than -2. We're keeping it on this side of the red line, right? So we erase the above part. Now, it did not include -2. So on the red line, it didn't include -2. We've got to put an open circle where it hit the red line. Is everybody comfortable? Now, we know lines have an arrow, so I'm going to be really pretty today and draw it nice. Okay, now we can go ahead and move on and focus on the quadratic. So we're graphing -x² minus 2. If you don't know how to graph a quadratic, give me some points. So go. Type in your calculator, give me some points. Okay, xy points. Go, tell me some. 0, 0, -2. So I'm plotting that. Over 0, down 2. Then what?
1, -3.
1, -3. So I go over 1, down 3. What's another point?
2, -6.
2, -6. So I go from the origin over 2 down to 6. Awesome. Let's do the other side. Let's do some points over on this side. So wouldn't that be -1?
-3.
So I go to -1, -3, and then -2, -6, right?
Yep.
So we have our parabola. Nice and pretty drawn. Okay, we only keep that parabola though for the x values greater than or equal to -2. Our arrow's pointing that way, so we keep that way of the red line. Erase the other half. So we'd be erasing below, which guys, it should make sense. Aren't those the x values that are greater than or equal to -2? Okay? Now it did include -2 because greater than or equal to, the equals when we have the closed circle. And we've drawn our piecewise function. Questions? Okay, I'm going to do this problem, number 12 from yesterday's worksheet. If you want to get that out, if you didn't do that one. If you did, then just check your work. So this one is actually a lot easier than it looks. It originally is a little bit trickier, but we have 3 pieces in this piecewise function. So we're going to graph x minus 2. So we have a y-intercept at -2 and a slope of +1. So we draw in our line here. Okay, so we draw in our line. Now I'm going to restrict that. This restriction is at -1. So I'm going to have a restriction line at -1. So we keep that first line for x values less than -1. So we're keeping the below. So we erase the above. Now it's not equal to -1, so we have an open circle. Is everybody good with that piece? Moving on to the quadratics part. We're graphing x squared. So some points for x squared are 0, 0, over 1 up 1, over -1 up 1, over 2 up 4, sorry. What do you just plug into? What's 2 squared?
4.
4. So you guys see how you could, it's almost easier to just do this one in your head. What's 3 squared? 9. -3 squared is also 9. Okay, so we have our parabola. Let's draw that in. Now we keep that parabola. Looking at our restriction lines, we have a restriction line at -1, but also +1, right? So I'm going to draw in my other restriction line here. Now we keep the parabola for x values between -1 and 1. So the x values have got to be greater than -1, which would be this way, but less than 1, which would be this way. So then we erase anything else. So this doesn't fall within, and this doesn't fall within those restrictions.
I don't get that, because you should keep that left side.
Nope. X values greater than or equal to -1. So only greater than -1. Or equal to, not less than -1. So greater than or equal to -1. So aren't the So these are the x values that are greater than or less or greater than or equal to -1.
I think the confusion is stemming from the arrows pointing that way.
Oh, yes. Yeah, good point. Okay, so you got to read it. It eats the bigger thing. So do you see how it's eating x? So it's greater than with this one? Gotcha. Is there a better way of explaining that? Can anyone help me out?
It's just saying it's like x is greater than 1. How it says x is greater than. It's like saying x is greater than or equal to -1.
Right. Right. Are you seeing it a little bit better?
Yeah.
Okay. So then it's also less than or equal to 1. Now, these have equal signs, so these are going to be closed circles. Now look, it's bouncing, our parabola's only bouncing between those restriction values, right? Which we're good. Moving on, almost done. This one was way easier, hopefully, today for everybody, now that we have some practice. X plus 2, that's just a line with a y-intercept of 2. I'm just going to do dots on this, so I don't have so much erasing to do. So we go up 1 over 1. That is a positive slope of 1, right? So up 1 over 1. And down 1 over 1. Now we keep that one. We keep that function for x values greater than positive 1. So here's positive 1. We only keep that function for the x values greater than 1. So we'll erase anything that does not fall in that criteria. It did not include 1. So we have an open circle where it hit 1. Questions on that? Did it seem easier today? Hopefully, usually when we see things second time. Okay, good. Okay. Okay, so today we're going to be working backwards, which is actually a little bit easier for the most part. You'll need your graphing calculator ready to go. So we're going to be given a function, and we're going to be writing a piecewise function. So instead of giving the function and drawing in the piecewise graph, we'll be given the graph and writing the function. So first of all, looking at this is an absolute value graph, right? The sharp V's. Does everybody see that? Okay, but also notice something. Couldn't we look at this as a piecewise function and say, don't we have a line right there? And then don't we have another line right here? Yeah? Okay. So we're going to write a piecewise function. So first of all, let's just focus on this yellow line and figure out what function does that represent before we write our actual answer here. So let's figure out what line that represents. Well, it's a line, and lines have the form y equals mx plus b, where m is the slope and b is the y-intercept, right? Yes. Okay, awesome. So where's the y-intercept? Positive 2. So we're going to have a plus 2. What's the slope? Good. It's 1, but it's also negative 1. It's negative 1, right? So here's a little thing to help you kind of think about this. So first of all, you'll look at whole number points. Aren't we going up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1? So we know our slope's 1, but not only is it 1, if we step on that line, when we slide downwards, so that's a negative slope. So we have a negative 1x. So we have y is equal to negative 1x, so I'm just going to write negative x plus 2. Does everybody understand how that was that line? Now we have another line, this blue line. That's y is equal to mx plus b. It's a line. That's the form of a line. What's our y-intercept on this blue line?
X plus 2.
It's plus 2, good. And then our slope is up 1 over 1, up 1 over 1, up 1 over 1. If we step on that, we have to walk uphill. That's a positive slope. So we have y is equal to 1x, which is just x. Okay. Is everybody good so far? So we're not done yet. So now we know a piecewise function contains different pieces of other functions. So our piecewise function is one function, like this. F of x is equal to. Now we have this function and this function. So let's put those in. Those are the two pieces that were in our piecewise function. So we have negative x plus 2, and we have x plus 2. Questions up to here. So now we have to put in our domain restrictions. So we're looking, where does this line change? Where does it stop?
0.
At 0. Does everybody see how it stops at 0? And then doesn't this function start at 0? So our domain restriction is going to be at 0. So think about it. This line, this negative slope line, isn't this going to be for x values less than 0? So we'll say this is our function for x values less than 0. Is everybody comfortable with that? No questions? And then this is our function, this blue one, the second one, is for x values greater than 0. Now look and make sure your arrows are pointing the right way. We kept this one for this side, which is good, right? And then we kept this one for this side. So arrows pointing the right way. Now also, if we just write it like this, won't we have an open circle because there's no equal to? So that's not true. It's closed circle, so we need to put an equal sign on one or the other. You won't put it on both or else we've double dipped. Does that make sense? Either or will work because it will close off the circle. Okay, any questions? Okay, we need a couple more till we get good at this. Okay, so So here we go. This was a piecewise function. So first of all, we're going to look at the section. So I'm going to just do it in color this time. Isn't this a section? Let's figure out what that equation of that line is. So we need the y-intercept, right? And then we need the slope. There's two ways of doing this, an easy way and a more complicated way. Either way will work. Well, easy way is, if we have a bunch of points, can't we type those points into our calculator? It will give us the regression line, the linear regression line. That's how I'm going to do it. So you use at least 2 points to find the line. So this is a point on the line. So that's negative, I'm randomly choosing it. That's negative 7, negative 1. That's a point on that line. And then also another point on the line, any point will work, negative 5 up 1, right? Does everybody see that? So I randomly chose those points. Okay, so go stat. Everybody. Stat. Edit. Into list 1, type in your x values, negative 7 and negative 5. In your y values, in list 2, type in your y values, negative 1, 1. Hit stat again. Calculate, right? And down to the line, because this is a line, linear regression line. So you get y is equal to what?
X plus 6.
X plus 6. Did everybody get that? Did anybody not get that? Did you get it or not? Yeah. Everybody. Okay. So we know that that's that line. Let's keep continuing to figure out what the other line is. So now we have this line. You're not going to type this one into your calculator because you should be able to eyeball it 10 times quicker. Isn't this a straight line with no slope?
2.
So it's y is equal to 2, right? Straight line at 2. And now this one, once again, we'll want to do some points or do it the hard way by continuing to graph it, find the y-intercept, find the slope. So I'm just going to use that same method I used. Find some whole number of points. So over 2 up 2, that's a point on the line. And then over 3 up 5, that's another point. So type it in your calculator. Give me the linear regression line. 3x minus 1. So we have those 3 functions. So now we can write our piecewise function. So we have one function, f of x, is equal to, it has these 3 pieces. So it has an x plus 6, it has a 2, and it has a 3x minus 1. You type it into your calculator, and then it'll give you the linear regression line. You know how to do that, right? Stat, edit. We just did that on this one. You said you got it, so you can do it on this one. So stat, edit, list 1, type in x values, list 2, type in y values. Okay, questions before we restrict our domain. Okay, let's do that now. So we have our domain restriction. This function stops at this x value, right? Everybody? And then this function starts at this x value, ends at this x value. And then this function starts at this x value and goes onward. So now we can go ahead and put in our domain restriction. So for this line, that was our first one. Yes?
For the equation, isn't this like 3x minus 4?
Was it minus 4? I don't know. I just took everyone's word for it.
Yes, 3x minus 4.
3x minus 4. Okay. So 3x minus 4. Thank you. Okay, so putting in our domain restrictions. We have this line, x plus 6, and that was for x values. Isn't that less than negative 4? Everybody, do you see it? That's negative 4. So x value is less than negative 4. Now this line started at negative 4 and went to 2, right? So this function was for x values between negative 4 up to 2. So I say negative 4 less than or equal to x negative 4 is less than or equal to x, which is less than or equal to 2. Do you see how that's putting that function between negative 4 and 2, everybody? Now, the reason I put in the equal sign is to close off the circle. So wasn't there an open circle on this negative 4? So I needed to close off the circle on this negative 4. Does that make sense, everybody? Because it wasn't an open circle. So then on this one, I did a closed circle. So just keep that in mind. So these are closed circles. And then we went up this way for this line. So that started at x is 2, right? Isn't that for x values greater than 2? Not equal to 2 or else we've doubled it. Does everybody see how to do that? Okay, do you need one more?
Yeah.
Okay. This one?
Yes.
Okay. Here we go. So let's go through this one quicker, guys. If you'll all help, we'll go way, way quicker. So let's all be ready to chip in a different way. Okay, here we go. So let's write out the few different functions. So let's figure out that function. Go. Somebody tell me that function. The next, somebody else. What's this function? That one's quick. Let's all look at that one.
3.
Y is equal to 3. Okay. Next one. Somebody figure out that one. So put some points into your calculator, right? You guys know what you're doing, right? So let's find this line. Go. Put in some points on that line in your calculator. A few of us need to do it though so we can verify that we're good. So negative 9 up 1 is a point. And then also looks like negative 8 up 3. What line is that? Anyone? Got it yet?
2x plus 19. 2x plus 19.
Okay. 2x plus 19. So we have y is equal to 2x plus 19. Awesome. Now what about this line right here? Let's do that one. Somebody else do that one. This one's x plus 19? Okay. Did you put it in 2 points? Oh. Yes? Oh, x plus 9. Okay. For which one? This one. Okay. So x plus 9. So we have y is equal to x plus 9. That was for this piece. Is everybody comfortable? Okay, I wish I had some more colors up here. So what is this one? That one you should eyeball it. Y is equal to 7. And then this one is one big line. Class 1. Let's put in some points into our calculator. So there's a whole nother point at 3, 3. And then at 4, negative 1. Those are 2 points we could use. Any points will work though. Anybody else get that?
Yes.
You get it? Okay, awesome. So now we're writing our piecewise function. We're going to have all those pieces. So we have 2x plus 19. That's for x values. There's our restriction line, right? Everybody? X values less than or equal to negative 8, right? X values less than negative 8. Is everybody comfortable with that? I'm kind of going fast. If I need to slow down, I can. Okay, y is equal to 3. So we have a 3, and that's between, maybe I'll do it in, I don't know. So we have it between here to here, right, everybody? So that's between negative 8 to negative 5. Is everybody good?
Yeah.
Okay, so we have negative 8 less than or equal to x less than or equal to negative 5. Then we have x plus 9, and that was between negative 5 to negative 3. So negative 5 less than or equal to x less than or equal to negative 3. And then we have a 7. And that was between the x values of negative 3 up to 2. A little bit tricky to see. So negative 3 up to 2. And then we had our negative 4x plus 15. And that was for x values greater than 2. Okay, so let's check to make sure. Uh-oh, I double dipped on some of these, so I need to go back and fix because I got going fast. So we have an open, we don't have it including negative 8, here we do. So we've closed off our circle, right? Here we have it including negative 5, so this one can't include negative 5 as well. Is everybody seeing how I'm fixing them? Right? So this one includes negative 3, so this one can't include negative 3. This one included 2, so this one can't. Okay, so I fixed the double dipping I've done. Pretty easy fix though. Okay. Last one, because when I didn't show this one first hour, I couldn't do it, so I'm sorry it's been a really long lesson, but I will give you the rest of the time to work pretty much. Look up here. So it's for your benefit, and then I'll just give you the rest of the time. I know it's a long lesson. Stay with me just for one more thing. So it says, given this function, graph and write a piecewise function for the graph. So I won't go all the way through this one, but don't we know how to graph this?
Yeah.
We just learned that a couple days ago. First, we determine our shift left and right. Anything added with x, doesn't that shift our function right or left? And we always go opposite, so good. We're going right 3, and then this is our shift up and down. Now once again, notice, This is added on the outside of our function, so that's just the up and down sign stays the same. So up 5. So that's our new starting point, right? 3 up 5. Now our slope, because these are v's, are -2, which is -2 over 1. So we'll go down 1, 2 over 1.
I did the absolute value.
And we'll do the other side. So we have this, right? And now can't we write a piecewise definition? This was like the first example I did.
Yeah.
Isn't this a line? Isn't this a line? This is the x restriction, right? You would just type it in your calculator if you don't know what the line is, right, everybody?
Yeah.
Okay, so I'm not going to continue. Okay, looking at this one, I won't go through it. But if we have this is f of x, and we have f of x minus 3, isn't that shifting it down 3? It's added on the outside, right, of our function? So when we just take this and shift it all down, 1, 2, 3, sorry, 1, 2, 3, so we'd have a function like this, and this one shifted down 1, 2, 3. Does everybody see how that shifted it down 3? With this one, isn't it added in with x? So it's our shift left and right, we always go opposite. So this would be right 3. So we'll take our function shift at 1, 2, 3, right 3, and then 1, 2, 3, right 3. Does everybody see how to do that? Okay, the rest of the time is yours. I won't come up here again. So you're doing all of that worksheet except for that little packet, which is actually really short, except for number 5. You can cross out the number 5s.